Hello everyone, today is December 8th, 2025, and I'm going to talk about Word2Vec. So this is a good, like a beginner's model if you want to get into the field of deep learning. So basically, it's coming from this paper from Google. The title is called Efficient Estimate of Word Representation in Vector Space there. So if you're interested, feel free to download the paper, Google the paper and download and read it. But if you don't understand, that's also fine. I will try to explain in a really easy to understand way. So hopefully ordinary people like me can also understand. So pretty much I I won't get into any theory in this point there, but I will explain what it is, and let's directly get into the code. So basically, I have this terminal. I create a new folder just called Word2Vec, and I have a Jupyter notebook set up and also a requirement. So first of all, let's look at the requirement to set up the environment. So basically, we're using an package that I found is really convenient. It's called Gensim, and scikit-learn. It's a typical machine learning package that help us do some machine learning routing stuff there. And of course, we need a IPY kernel. This is for Jupyter to be able to run Jupyter Notebook, to be able to run that. So if you don't know how to set up Jupyter Notebook, you can check my other video on how to set it up with cursor. So we're gonna use cursor, but we're probably not gonna use any AI, just use it as an IDE. So first of all, let's create a virtual environment. So I already have a virtual environment here, but let me just deactivate it for now. Just assume that we have like a pure clean environment. We have nothing. So first of all, we use UV to create a virtual environment. Yep, that's done. And then if you have like ls-a, so -a means like all. It will list out all the directory under the current directory, including the one start with star. Usually a system file is hidden from like a normal ls, but if you use that .a, you can see it. And now let's install like the requirement for this virtual environment. So again, so we're gonna install these three packages, Gensim, scikit-learn, and IPY kernel. So we can do like a UV pip install -r. R means recursive. So it will recursively install every package list in the requirements.txt file. Yep, so it's pretty fast. So UV is a new Python package management software. It's super fast. Like usually you install this many packages in like a normal pip, it would take much longer time, especially there's some big packages like NumPy, scikit-learn. This itself will probably take several minutes, but like a UV can just finish in seconds. So now we are good to start our code. Let's just bring up like cursor. Cursor dot means like I'm using cursor to edit the current directory. So can take a look at the notebook that I prepared. So first of all, we just import Gensim, and then from the Gensim model, we import Word2Vec. So let's run it. So to run this, we can like command enter to run this code block. The first time is gonna take like some time because Gensim, it's like a big package. It takes some time to import to memory, but after that, it should be pretty fast. So while this is loading, we can look at the structure of this notebook. So the first part is to prepare training data. And the second part, prepare training data, train the model, and then save the model to a .model file. And once this is ready, is done, then we should have a model that we can reuse for our inference task there. So we load the model and then call the model to look up like a token into its embedding, and then finally compute like a cosine similarity of those two vectors. So that's the overall of, we'll go through this in detail. So now the import is done. Let's look at the training part. So this is how the training data will look like there. So basically, the training data is a list of lists. The internal list are lists of tokens there. So I just call it T1, T2, T3, T4. In reality, it should be like a natural languages sentences. For example, it's a good day today. Like how's it going? Uh, like how you doing? That kind of like natural language sentences that will speak like in our day-to-day life there. And then we can feed this data as training data to the Word2Vec model. So we call the Word2Vec model and the sentences as input to use data to feed into the sentences field. And then the vector size basically is like, so what the Word2Vec model would do is basically to convert each token. So from now on, I would just call each word a token because that's the terminology the industry has been using. So basically each token would be converted to like a 50 dimension vector. So a vector is just a list of numbers there. So any word that's in the space of the sentences will be converted to its own vector with like a 50 as a dimension. And the window, there's also window and min cal and SG. We can just ignore those for now there. So that's not to confuse you at this point. And then once we finish like the model equals this, the model is chained by just this one liner. So right now, like this Gensim package has made like Word2Vec really easy. As a developer, we just need to prepare the data, and then the model is chained. And then we can save the model to this file. So now let's run the code. Command Shift Enter. So this is already finished there. So we see this. There's a new token embedding token embedding start model file, which is the output the model there. Now, once the model is ready, we should be able to use it. So the way to use it, first of all, we loaded the model from the file. So we call it like the Word2Vec. So this Word2Vec again is imported from Gensim, Gensim.models. Call the load function, give the file name, and then what you can do is probably like look up the vector from the token. So the way to do it is this loaded model called the WV. WV stands for Word2Vec, and then give like the token in the square bracket. So here it kind of suggests that the WV is basically like a dictionary kind of data structure. We can confirm that later. So, but right now just take it as a flag there. So the model itself is just not internally, it's basically just a giant mapping for each token. It mapped the key is the token and the value is a list of the numbers as the vector. So that's exactly where the Word2Vec is coming from there. So mapping a word to a vector. So embedding one, it's the token one's vector. We're just gonna print it, and the same we do the same for token two. So let's try to run the code. Yeah, this will print out like a token one's vector and token two's vector. So as we say, the dimension of this vector should be 50 here, and here is the same. Probably can run some code to confirm this. Let's add a code block here. So let's do like a length of like a embedding one. So to confirm that this is 50, and also the model, this is the model itself there. So we probably can print out a model. Yeah, so the model itself is like a data structure. So, but it can be looked up by like a sort of like use it as a hash map. It kind of doesn't print it out directly. I don't know if this would print it out. Yeah, this is just print out a summary there, but maybe I think maybe we can do something like a key in this and print the key. Probably let's do a format print. So yeah, let's see if this will work. It doesn't like this kind of structure, but anyway, just take it as a fact. This what load the model.wv would be just add the sort of like a map. So let's delete this cobra not to confuse people. And finally, we can call like a scikit-learn. So scikit-learn provides a functionality called cosine similarity. So I won't get into details about cosine similarity in this video, but basically it's gonna compute a distance between the t1's vector and t2's vector, and then give you a single number that's between -1 to 1 there. So if it's to 1, if it's closer to 1, that means like two vectors are very similar. That means the two words are really close to each other. And then if it's -1, that just means like the two vectors are opposite to each other. That means they are very, very far away. So right now I just compute the cosine similarity between embedding 1 and embedding 2. So yeah, importing like this would take some time there. So why this? Okay, so now it's giving us the similarity between T1 and T2 is -0.17 there. So that's usually the application for this model is like you given one word and then convert it to vector, and then you give a bunch of the other words and convert them all into the vector. And then you compute the similarity between this given word and all the candidate words. And then each one of them would get like a distance there, and then you sort it by the distance by. So, and then you can get a list of the word kind of rendered in like in an order that closer to the given word would rank higher. So that's usually how this model is being used in real life, like for example, like a recommendation system, like a candidate generation or feature engineering. Yeah, that's pretty much the simplest introduction to use Word2Vec, like in a real setting environment. So with this, even you don't read the paper, you can just start playing with the simplest deep learning technology. If you found this video helpful, please smash the like button. It really helps support the channel. And don't forget to subscribe for more content like this. Subscribing also helps the algorithm recommend similar videos to you. Thanks for watching, and I'll see you in the next one.